Hello, AP Stats students. It's Mr. Slagle coming to you from Minnesota here, and well, this room looks really dark and dingy. Need to open the lights, window up. Oh, that looks terrible. I'm gonna just leave her like kind of open, so it only kind of looks like The Shining. We're gonna get started with our first official math lesson today. So let's go ahead and jump right in. Transition. Greg, hit the transition. Thanks, Greg. All right, please title your notes. 1-0 statistics intro. Here I have. You're like, wait, what the heck's going on here? What is this? The Ishango bone. You know, I just recently learned about this bone, or re-remembered it, and you're probably wondering what this has to do with statistics. This is probably the earliest known theorized mathematical artifact to ever exist. And I'll let you read what's on the screen. But basically, it's potentially from approximately 20,000 years old. Well, actually, on the website that I was on, it said 20,000 BC. But it's somewhere in there. Some sort of maybe have been used for counting, but deliberately these notches were put there. This is kind of like maybe the first artifact to the insight of human mathematics. The reason I'm showing you this, it has to do with when math started to show up. Because I want you to have an appreciation for statistics, the course that you're studying. And it's really, in the grand scheme of things, really brand new. I'm going to show you where this is and kind of where certain math started to show up in this timeline. I'll be going to the website, let's see, this website here, after I drag this over. That says like mathagon.org/timeline. So let's go check that out on the desktop here. So here we have, this is kind of like a timeline you can slide. Here's that Ishango bone. And then here we have people starting to do some geometry. These are like some Pythagorean triples, I think, that were developed later. So we have like early counting, early record keeping done on clay tablets. I think there's like the Mesopotamian type math going on a long time ago. We have early Brian papyrus, really important. And then we keep going, and I think right around in here is when we see like the beginnings of evidence of algebra showing up, which is pretty interesting. So algebra is something that we teach in high school. In fact, it's required for students to graduate, and it's like, potentially the beginnings of it are 4,000 years old. So we flash forward in the future. I don't know if you can see the dates at the bottom. This is 2000 BC, the beginnings of algebra and geometry and stuff. And then we start getting into some famous names. Pythagoras, you guys know the Pythagorean theorem. Euclid wrote Euclid's Elements. So we're talking about like 300 BC, which is one of the most printed books in the history of humanity for formalizing geometry and starting with basic things. I have a bust of Euclid on my desk, or at least I did at some point there in the classroom. Eratosthenes, I believe he showed the Earth was round. So we have some really geometry heavy starting to show up. Let's keep going. Okay, we're still doing some cool stuff with math, maybe some trig, moving on, flashing forward, math getting a little bit harder. Al-Khwarizmi is famous for coining the term algebra. It's a kind of like a Middle Eastern word, and he kind of formalized a bunch of algebra, and this is about in the year 800, it looks like, okay? Year 800, that's 800 AD, or CE, Common Era, whatever you want to call it. Okay, we've got more math coming through. You can click and learn about all these people in this math time, which is pretty exciting. So where does statistics start to show up? Where does stat start to show up? John Napier was like logs, some other cool things, logarithms. Euler, maybe starting a little bit, we're getting there, and it's actually not until, oh man, we're talking about very recently. I'm looking for Gauss. I should have spotted him beforehand. I'm not seeing him in here. It's not until way later, like 18th, 19th century, somewhere in here, that we start to see statistics show up. So the reason I'm showing you this is, and in the grand scheme of mathematics, stats is very new. It's very new as to what we're doing and what you're learning. So you should be excited. This is some of the newest math you will have learned, and we're just beginning our journey. I know we're just on the beginning here, but it's an exciting journey. I want you to know where it sits in the history of math as well. So let's get started. Let's jump in and do it. Here we go. All right, so what is the science of statistics, right? There's kind of two definitions I can give. There's statistics, the process, which is what I'm going to define today, and later I'll tell you what a statistic is. It's kind of something else, but that's for another day. Statistics is the science and art of collecting, analyzing, and drawing conclusions from data, and that should go in your notes. So any definition that's on the board today, please write in your notebook. We've got an election coming up. It's an election year, and we're going to be voting. And so, when you're collecting information from a population, what's the best method to collect? And you know what? People don't even agree on that. So there is a science to this. There is potentially an optimal method that needs to be found, right? You can do mail-in ballots. You can do ranked choice voting. You can do just straight up fill in the bubble paper ballots. You can do computer scanning ballots, all sorts of things. So there is a science to the collecting of data, and we are going to talk about those methods and what problems certain methods can have, and what are the correct techniques for collecting data so someone can't throw out your information or the data that you've collected. How do we analyze that data? Once we have it, what do we do with it? Okay, that's a whole nother discussion that we're going to have. And then lastly, once we've analyzed it and we have some numbers, how do we make sense of the data that we have? How do we use that to make a decision or draw a conclusion? And that's going to be mainly what happens in semester 2. And Mr. Stubbs was actually the mayor of Talkeetna, I think, for several terms. So this is actually a true story. There was a cat that was the mayor of Talkeetna, Alaska. So you can look that up. It's on Wikipedia, and the internet never lies. But I'm on the internet, so I can say whatever I want. Here we go. I'm not in class. Internet never lies. Moving on. Okay, I want you to pause the video, go to the class website, and take the survey that is currently linked there, and then unpause the video once everyone has had time to take the survey. Try to answer honestly if you can. If you feel any of the questions are an invasion of your privacy, you have the right to not answer them, but I'm pretty sure they're not too bad. So go ahead and answer them, pause the video, and I'll pause my recording and make sure that I actually put the link up, and then we'll come back in just a sec. I just checked. We got the survey up there, so we're feeling good. We're ready to go. So let's. It's not up here yet, but I checked on my website updater, and it's there. So hope everyone took the survey. We're about to get started and keep moving on, and that will become relevant here in just a minute. I do have to make sure I have it pulled up though. All right. So our first 3 important definitions, I have them color-coded because they all are kind of tied together. I want you to see how they're tied together. So while I'm talking, I'm going to slowly go through each of these. Make sure you write them in your notes. Let's go ahead and get started. So these are very vague terms. I'm going to try and put them in context of individual studies or research questions here in just a minute. So first one is population. Population is the entire collection of different individuals being studied. Individuals can be many different things. Anytime you have a research question, depends on what you're curious about, and that tells you what the population is and what the individuals are. Okay, so the individuals are the things that you are taking your measurements from. Where is the data coming from, right? The data is coming from something that's being studied. So that could be people, it could be trees, it could be, constipated shih tzus, whatever you're trying to study. It could be roads. You could be looking at the quality of a road surface. It doesn't have to be something that is alive. It could be street signs. I'm stuck on a highway for some reason, I'm not sure. Okay, population and individuals. Individual is an object described in the set of data. They can be animals, plants, things. And as we can see from the drawing over here, the population is the entire collection of individuals, right? So kind of the population of individuals are related. One of them is a single entity within the population. The population is that entire collection. What's tough about statistics is just like if I want to determine who the new president is or who the new mayor of Talkeetna is, you can't get information from the entire population. It's probably not possible. Like, for example, in class today, if I gave you guys a survey today, perhaps not everybody was in class today. And so I wouldn't be able to get information from the entire population of my class if that's the population of interest. Okay, if I'm trying to understand my class, my stats class, then that's my population of interest. Okay, a sample is generally a subset or a portion of the individuals in that population. And normally we can't get them all. We can't get everyone to cast their vote on election day, and we can't maybe take measurements on every tree or every constipated Shih Tzu. Right? It's not possible. It would be too hard to gather all that data. So as statisticians, we have to decide how are we going to only select a small amount so that the amount that we select is useful information. We're getting useful information from those individuals that we have selected. Okay? Yeah, I think that kind of makes sense. Hopefully it does. And you're going to see some more examples in just a minute. So make sure you have these 3 definitions before we move on to the next slide. Feel free to pause the video if you'd like. Hopefully that made sense. Population, everything in question. Individuals, each of the dots. Sample is what we gather to collect data on. All right, so in this class, there are 2 types of statistics that we're going to discuss. In semester 1, we're going to be talking about descriptive statistics, which is organizing and the summarizing of data. We're going to be doing that in semester 2 as well, in addition to inferential statistics, which is where we have our data collected, we've organized it, we have done some summarizing of the data and displaying it, and we know what it means, and now we're going to use that to draw our conclusions. So the conclusions come in semester 2. I think I briefly mentioned that in the introduction video, okay? Statistical inference methods, there's a bunch of them, and they all depend on the type of data being collected and kind of what the question is that's being asked. So basically how, semester 1 is like, what is a graph, what's a graph look like? How do I make a bar graph? Like that. These are the types of questions we're asking in semester 1. How do I make a bar graph? And then once I have the bar graph, what do the bars mean? So on and so forth, that kind of thing. We're also saying like, all right, well, how do I go in, how do I get a mean or that kind of stuff? That's all descriptive statistics, okay? And so there are many different tests that, or different types of inference that we're going to be doing in semester 2. So we might be saying like, a good example is like before an election, right? We don't necessarily know who's going to vote, so we do like an early poll to guess what the voter outcome is going to be, right? And that poll is not everyone that's going to vote, but it's probably a subset of those that are going to vote. So that's what this class is laid out, how it's laid out, and what you have to look forward to. Now, if I remember correctly, I believe 2 years ago, last time this class was offered, we had a good chunk of time for people to prepare and study for the AP exam. I want to say a week and a half or 2 weeks. 2 weeks, I think, of just straight kind of in class. Maybe it was a week and a half of studying time prior to the exam. And yours is, I believe, a little bit later even this year, so that's good. Okay, here we go. Next vocabulary word, you're getting a handful here, is variables. So once we collect our data, or we've selected our sample of individuals, and we want information about those individuals, the types of information that we ask or collect are the variables of those individuals. So it's an attribute that can have different values for different individuals, and really, sometimes at different times. So, right, time is generally one of the variables in question sometimes. So, for example, if we were looking at the constipated Shih Tzus again, it would be, variables. What are some characteristics of these Shih Tzus? When was their last meal? What did they have at their last meal that maybe may or may not have made them constipated, right? Have they eaten a squeaky toy in the last 24 hours? All of these things are pieces of data, questions that we can collect in order to make a decision. Or maybe we can find some commonalities between these dogs, small dogs. I hope everyone knows what a Shih Tzu is, or else this is going to be real confusing, okay? And you'll notice that I asked a couple different types of questions there. Variables fall into two categories. There's numerical or quantitative variables, and that's when the variable takes a number. So if I had said, how long ago did your Shih Tzu eat? That is a quantitative variable. It is a time that we can specifically measure, okay? What did your Shih Tzu eat is not quantitative information, it's qualitative information. It falls into a specific category. It assigns a label onto the variable being collected, okay? And sometimes those categories it's as specific as, the dog ate this, or the dog, this was the last meal, or this is the last time that they had water, something along those lines. The last meal was, last time they had water would be numerical. The last, what they ate, you could fall into like standard dog food, like squeaky toy that they weren't supposed to eat, cat food, garbage, whatever. And then people could select from the options. So you'll see these a lot of times in surveys as drop-down menus or check boxes or something. These are categorical variables. Okay, I hope that makes sense. Every variable that we collect falls into one of these two categories. Pretty exciting. All right, let's move on. Hopefully, make sure you have these written down, and then once everyone does, you can move on to the next slide, and we'll go over some examples. All right, let's look at the survey that you took. Okay, so when you're looking at the survey, what is the population of study? Who were the people that I was trying to understand for this research question? Okay, in the survey you took, who are what are the individuals that I'm extracting information from? Those individuals are you. Okay, so that would be the population is Mr. Slagle's. Is that thick enough? I hope so. Mr. Slagle's AP Stats students in 5th period. And I could be even more specific. In 5th period, this is on what, the 20th? On 8/20/2024. Or I could say, I think that's technically not right, because I was trying to study the whole class, and maybe someone didn't show up. So if I'm being really specific here, it could be that I'm in 5th period, and I'm going to say in 2024. So who are the people that are enrolled in my class? That's the population of study. Now, I have 31 people enrolled in this class, and I maybe didn't, I didn't get everyone to show up, or not everyone showed up to hear my video lesson today. Makes me sad. But maybe they did, okay? The sample are all who responded, all students who responded to the survey on 8/20/2024. 2024. Okay? Now you can see how specific I'm being. I need to be very, very specific. So the population, you need to be ridiculously specific as to who am I trying to understand, and the sample is who reported, right? And you might, if I was in class, I would actually say this, the count, right? I would say all the students, maybe I'd say all, 28 students that reported. Maybe it is 31, and that's great, okay? Let's see here. Okay, let's see, and then let's move on to the individuals. Let's do this real quick. Hold on, I gotta fix something really quick. Look at that. All right, we're back. We're taking a look at this response here. So what are the individuals? What are the individuals? Because I said not always people. Some people might say, are they the questions? No, this one's actually pretty simple. The individuals that the data is coming from, the data describe what? The data don't describe the questions. These data describe the people. So the individuals are each student. Each student sampled in Slagle's 5th period. All right, now this is where it gets interesting. I'm going to pull up my survey so I have it in front of me, right in front of me, and you guys can have that in front of you too. Let's look at the different categories that we collected information on, or the different variables. What were the different questions? Well, I asked about your class standing, right? What class standing was one? That is a variable. That is a specific type of variable. Is that, now think, is that categorical or is that numerical? Is that qualitative or is that quantitative? Class standing is not necessarily a number. I mean, you could say that. You could say it's 9, 10, 11, 12. So yes, you could say that is numerical. As it is currently written, to me, it looks like it's not in the form of a number, it's in the form of a word. So I would call this qualitative. It's in the form of freshman, sophomore, junior, senior. It's a label, okay, based on how the data is written. Okay, great. Let's keep going. Next question. Number of siblings. So number of siblings. Awesome. Number of siblings is, of course, a number, so this is quantitative, and I'm going to say quan for short. Let's just get all the variables out there. Now this one is a little bit confusing. Zip code. Zip code is a number, but is it being used, if we go back to this definition for numerical, it takes a number of values that are quantities, counts, or measures. Okay? Are we measuring somebody when we're looking at their zip code? Or is it mainly kind of a category that we place somebody in? So although they are numbers, I would actually qualify a zip code as qualitative. You guys are going to hate me for that one. But that's actually like one of these dirty AP questions. And the reason that it's qualitative is because they're kind of buckets labeled with numbers, if that makes any sense. It's not like, oh, let's march through the zip codes and there's an obvious order, there's an obvious count, there's an obvious measure. It's kind of just like a bucket with a numbered label. Okay, let's take a look at the next one, which was number of years in Fairbanks. Years in Fairbanks. This one I would also say is qualitative. Okay, this one is qualitative because I gave you a range. Again, it's buckets, right? It's not a numerical response, it's a range of numbers that's your response. So it's like these little cups that I'm placing your response in, and not necessarily a definitive number, if that makes sense. I could have asked that question. The way the question was collected, I could have changed it so that it was a question. So if I had said number of years in Fairbanks, North Pole, and then I left it a free response question, and then you guys reported numbers back to me, that would be a quantitative variable. It depends on how the question is framed, so you have to be very careful. Okay, I am right-handed, left-handed. Okay, I'm going to put a dot, dot, dot. We're going to go through these verbally. Right-handed, left-handed. You guys decide. Shout out loud. Shout really loud. I want you to make sure Myram's class hears you. You can say qualitative or quantitative. You're probably already shouting by now. All right, number of languages you speak. That's definitely quantitative. Very good. How far is your commute to school in miles? Be as specific as possible. Okay, that's a good one. Commute in miles is definitely a number, and it's maybe it could be like 47.345. Okay. Now we're going to break this down. We're going to go into more detail there. But certain numbers, like number of languages you speak, you would report that, or number of siblings that you have, you would report that as a whole number. Like I have 5 siblings, or 2 siblings, or no siblings. Okay. And I have a really annoying sibling named Jeff that just won't leave me alone, or whatever, right? It's a finite number, 2, 3, 4, 5, 6. Okay, we call these discrete numerical variables because they're definite locations. Okay, right? 4, 5, 6. However, if I said how far is your commute to school, well, that's more of on a sliding scale, right? You could say like, well, I'm 3.752 miles away from North Pole High School, Mr. Slagle. That's what you might say. And so we'd say that's a continuous variable because I could slide a foot more or an inch more and you'd be further away and you could report a different number. If that makes sense? So we'll go over that later, but that's the difference between a discrete numerical variable and a continuous. We'll talk about that in a little bit. So all I want you to understand for today is population sample variables. Be able to read a story and understand, or read a study and understand what's the population in question. What are we trying to study, right? I could have changed the population for this to say like, it's all AP Stats students in the school district or something, right? But then my sample should include all other classes as well. So we'll talk about that in a minute. All right, cool. Let's move on to the next example. You guys try this one on your own, if you will. Take a look, talk about this. So we want to understand the type of vehicles that students drive, okay? We want to understand the types of vehicles that students drive. We're trying to ask some questions about student vehicles. Great. So, see if you can fill this out, or you can work along with me in the video. You can pause and do some brainstorming. Why don't we pause the video, do a little brainstorming, think about it for a minute, give them a couple minutes, and then we'll unpause and go through it. So, the population is usually starts with the word every or all, is every vehicle, NPHS students, every vehicle NPHS students drive to school. Could drive to school even, right? But maybe there are days where someone doesn't drive because they ride the bus, or maybe people are commuting with friends. I want to understand the population is the whole thing. It's everything. I want to understand every single vehicle that might be driven to school by a student, okay? All right, cool. All right, so what's the sample? What's a sample that we might be able to collect to understand these vehicles? We might look at, let's look at I don't know how many vehicles would be in the parking lot. Let's look at the 85 vehicles in the student parking lot. Interesting. Okay, and whatever. That's not a great T. I don't know why I did that. The 85 vehicles in the student parking lot. The individual cars. Cars and trucks. present. Okay, and what are the variables that we might collect from cars and trucks? Let's run through them real quick. We might look at the year manufactured. Is that qualitative or quantitative? And I'd say that would be a discrete quantitative or discrete numerical variable. Definitely a number, so that's cool, and it is measured when it was made. You might look at the value. What is the value of the car? Basically, how much is the car worth? Well, that might be based off how many miles. You could collect information on mileage driven by the car. That is a numerical variable as well. So year, value, mileage. You guys could maybe brainstorm a couple more as a class that I'm missing. Those are all numerical variables. How about qualitative variables? Color. Let's see. Color, condition. They look new. Tire type. Whoops. Could have just said type of tires, I suppose. So on and so forth. These are all variables. These are all qualitative variables, and the list goes on. I'm sure you guys can list many, many more that that are escaping me at the moment. Condition. Are the windows tinted? Qualitative. Nice. Does it have 4 wheels? That's qualitative. Okay. Nice. Good. Okay, moving on. Let's wrap this baby up. All right, so the last vocabulary word that you need to know before I end the video here is the distribution of a variable. And I'm going to use this word over and over and over ad nauseum in this class. And so it's good to have it written down somewhere as a reference. The distribution of a variable tells us what values the variable takes and how often it takes those values. The example of a numerical distribution that we saw was with our Parkinson's activity last time, right? You guys created a dot plot on the board. That is the distribution for the trials of the simulation that we did as a class. I think you guys did like 62 of them, and it's a beautiful curve. Beautiful curve. It tells us what are the values that can be taken by that variable, the variable being the number of correct guesses in the simulation. Okay? So it shows every possible outcome of the trial. You could have 0 correct, 1 correct, 2 correct, all the way up to 11 or 12. I see somebody got 11. That's good. Nobody got 12. That's okay. And then it also shows how often that they happened out of 62. And we could see that based on the number of dots that are present there, which is interesting. Okay, cool. So that's for a numerical distribution. A discrete, there are individual values. It's not continuous. You can't get 6.5 guesses correct. Okay. And then on the right, we have our categorical or our qualitative distribution. If you're looking at M&Ms in a bag of M&Ms, a large bag, and you're counting the colors that you observe, we have all 6 colors represented for our variable. The variable in this case would be the color of the M&M that we're measuring. And we have the counts, how often those occurred. This is a distribution. The one on the left is a dot plot. The one on the right is a bar graph. Okay, so we can see these different representations of different variables with different distributions, different graph types. And ladies and gentlemen, that is it for today's lesson. Your assignment is posted on the class website. You don't have to print it off. It's just there. You don't have to write the questions in your notebook. You can just put them in there. Put number whatever it is, number 1. Show the work. Make sure everything is labeled appropriately. The solutions are also posted. And my expectation for those are that you do not look at them until you have finished a question completely. So only when you finish a question completely should you look, and please have self-control to not look ahead at other answers if you can. Okay? Super. All right. That's it from me. I hope you guys are having fun and hope my lesson didn't derail too much. I had a lot of fun teaching it. In fact, this is the most fun I've had in a couple days, which is maybe that's kind of sad, but yeah. I'll give you an update soon. Okay? So thank you. Thank you for working hard. I can't wait to come back and be with you guys in person. See ya.